Please like and share my videos. Subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of July 2024. This question is from the section Linear Algebra and it is related to the concept of rank of a matrix. This question is from the part B, which is a multiple choice question. It carries 3 marks. The question ID is 704028. This question is suitable for JL, DL, TS set, AP set, IIT JAM and GATE examinations. I express my thanks to my student Venkatesh Sripath from CVR College of Engineering for participating in the discussions. Right. The given question is, let capital A be a 10 by 10 real matrix. Assume that the rank of A is 7. Which of the following statements is necessarily true? We are given 4 options. Option 1, there exists a vector V belongs to R power 10 such that AV not equal to 0 and A square V is equal to 0. Option 2, there exists a vector V belongs to R power 10 such that A square V not equal to 0. Option 3, A must have a non-zero eigenvalue. Option 4, A power 7 is 0. Right. Let's now discuss the solution of the problem in detail. We have capital A 10 by 10 real matrix. Rank of A is equal to 7. Right. We take directly option 4. A power 7 is equal to 0. Is it true? That's the question. Right. For this, we provide a counter example. Let A be a block matrix written like this. I7, the 7 by 7 identity matrix. 0, 7 by 3. It is a 0 matrix with 7 rows and 3 columns. 0, 3 by 7, 0, 3 by 3. Clearly, it's in the row reduced echelon form. Rank of A is 7. Agreed. So, it is a 10 by 10 matrix and the rank of A is 7. Now see, what are the powers of A? So, if you take A square, A cube, A power 4, A power 7, etc., etc., they are all equal to A. Thus, A power 7 is A, but A is not a 0 matrix. So, thus, A power 7 is not equal to 0. But in option 4, it is given A power 7 is equal to 0. Therefore, the option 4 is not true. Agreed. We go to option 1. There exists a vector V belongs to R power 10 such that AV not equal to 0 and A square V not equal to, A square V is equal to 0. A square V is equal to 0. Right. Let A be the same matrix as we have taken in the above, and its rank is, we have seen, it is 7, and A square is equal to A. Agreed. Let V be any vector of R power 10 such that AV not equal to 0. When AV not equal to 0, A square V not equal to 0, because A square is equal to A. Now, AV not equal to 0 will imply A square V not equal to 0, because A is equal to A square. So, this means there does not exist a vector V belongs to R power 10 such that AV not equal to 0 and A square V is equal to 0. Right. So, thus the option 1 is not true. We continue in the next slide for the further discussion. We go for option 3. A must have a non-zero eigenvalue. Again, we give a counter example. For that, we have taken the matrix A to be this matrix. That is, the first row is 0, 1, 0, 0, 0, 0, 0, etc. And the 1 is moving one step like that up to 7 rows. After that, each row is a 0 row, right? And if you see, so this is a 10 by 10 matrix. So clearly, rank of A is 7. You can see the block matrix. Rank of A is 7, and determinant of A minus lambda I10. That is, from the determinant, along the determinant, every entry in the along the diagonal, I'm sorry, not determinant, along the diagonal, you see every entry along the diagonal is 0. So A minus lambda I10 will be minus lambda will come along the diagonal, and when you take the determinant, because it is an upper triangular matrix, so this will be lambda to the power of 10. Minus lambda, 0 minus lambda is minus lambda 10 times, that will be minus lambda whole to the power of 10, that is lambda to the power of 10. So what are the eigenvalues? Equated to 0, so all the eigenvalues are 0. All the eigenvalues of A are 0. So if you see this one, this is in fact a nilpotent matrix, and a nilpotent matrix and all its eigenvalues are 0. So even otherwise also you can get this one. So the option 3 says A must have a non-zero eigenvalue, but all its eigenvalues of A are 0 in this example. Therefore, our option 3 is also not true. Now, option 2. There exists a vector V belongs to R power 10 such that A square V not equal to 0. Now what we say is we have already seen and shown that the options 1, 3 and 4 are not true. If the given question is a true question, and these are not true, you can conclude by the elimination. So you can use the elimination like this. Conclude that the option 2 is true, provided the given question is true. So the answer to our question is option 2, and that is the detailed discussion of the solution of this problem. Now our students will ask us, sir, why not you provide the proof for option 2? Yes, I will do in the next slide. We go for option 2, we want to prove it. That is, there exists a vector v belongs to R power 10 such that a square v not equal to 0. So the proof is we have this result related to the ranks of matrices. That is, rank of the product AB is greater than or equal to rank of A plus rank of B minus n. In our case, n is 10. Right. So this will put B is equal to A because we want A square. So how do we get A square from AB? Put B is equal to A. Then rank of AB will be A square is greater than or equal to rank of A plus rank of A minus 10. Right. That means rank of A square is greater than or equal to rank of A plus rank of A is 2 times rank of A minus 10. But our rank of A is 7. So rank of A square is greater than or equal to 2 times rank of A is 7 minus 10. 2 sevens are 14 minus 10, that is 4. So the rank of A square is greater than or equal to 4. Now apply rank-nullity theorem for A square. So the rank of A square plus the nullity of A square is equal to the number of the columns, that is 10. So the rank of A square greater than or equal to 4 will tell you that nullity of A square is less than or equal to 6. Nullity of A square is less than or equal to 6 will tell you the null space of A square is a proper subspace of R power 10. Null space of A square is a proper subspace of R power 10. So thus there exists a vector V in R power 10 which is not there in null space of A square. There exists a vector V belongs to R power 10 such that V does not belong to the null space of A square. So that this means there exists a V belongs to R power 10 such that V does not belong to n of A square means A square V not equal to 0. Yeah. If it belongs to, then A square V will be equal to 0. So V does not belong to the null space of A square will give you A square V not equal to 0. So thus our option 2 is true. So that's the proof of the option 2. Option 2 is true, and this is the only, so is a section B, therefore only one answer is correct. So option 2 is true. The answer to this question is option 2. That is the detailed discussion of this question from linear algebra, which is related to the concepts of the rank of a matrix. And this is definitely a good question. I am sure that you have understood the solution of this problem. Thank you for watching the video. Please like and share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.